All right. Hi, everybody. I just wanted to welcome you to our review. And this is a summary of what we talked about in class and trying to sort of integrate some of the things that we had been reviewing. So homeostasis is one in which we're trying to maintain balance. And as we talked about in class, we often there's a stimulus that's responsible for acting on a type of receptor. So this could be a change in blood pressure. It could be a change in the levels of calcium. It could be a change in other factors as well. Those are just some examples. It's picked up by a receptor that is being under the control, influenced by a control center, some kind of structure there. Maybe it's a hypothalamus, maybe it's another type of structure. And then this then talks to an effector, and usually when it's doing this, it is doing it through a hormone. And then once it does it through a hormone, then the effector has some kind of what I'll call a solution to try to help maintain homeostasis. So the stimulus here is something's gone off balance, and now we want to try to be able to recover back into homeostasis, one of the key principles in physiology. So what we looked at is that we looked at what was happening in the case of blood pressure, blood sugar, and blood calcium as examples of humeral control. And humeral control, think of like the blood as one of the four humors. That's the kind of the root of that word there and where it came from. And that's the first that we're going to talk about. So we'll talk about hormonal, which has a much broader type of effect and growth and metabolism and nutrient release, for example. And then we'll also talk about neural and how that works. So when we talk about humeral, what we're talking about here is that there are a couple of things that can be happening here. One is that we can have the calcium levels can be too high. So I'm just going to go ahead and put that right here, that the calcium levels are too high. And so the solution to that is that there would be a drop in the calcium levels, right, in the blood. Now, the control center for that, which a lot of you guys were able to sort out, was in the thyroid. So now we're like at this point, right? And then the hormone that the thyroid releases is calcitonin. All right. So if calcium levels are too low, then we want to increase the amount of calcium in the blood. And so in that case, then it's the parathyroid. And in that case, we're talking about the parathyroid hormone, PTH. All right, great. So blood pressure. If blood pressure is too high, then we want to drop that blood pressure, right? And if blood pressure is too low, we want to increase blood pressure. So how do we do that? If we want to drop blood pressure and have that kind of an impact, what you can do is that you can activate in the heart is what's known as atrial natriuretic peptide. And the atrium is the top part of the heart, and that's the one that actually releases that peptide. If the blood pressure is too low, then what you have is the kidney will be activated. And then this by releasing renin. And so, and the purpose of, and the benefit of this, the heart is, the atrium has stretch receptors that can pick up on this. And then in the kidney, these have receptors sensitive to the amount of pressure that's going through some of the tubules. And so if it's too low, renin gets released. If its blood pressure is too high, atrial natriuretic peptide can do it. All right, blood sugar. Increase in blood sugar. If it's too high, then what you're going to want to do is that you're going to want to drop the blood sugar. So you're going to want to drop blood sugar here. And here you're going to want to increase the sugar. Fine. And so the control center for both of these, in this case, is the pancreas. So I'm just going to write pancreas here. And in this case, it's insulin, and then that's released. Now, what is it that actually releases the insulin? And so you can ask yourself some of these questions and bear down on it, right? In this case, it's the beta cells that are present within the pancreas to be able to be able to respond to it. And in the case of what we're looking at for, in this case, this is glucagon. And these are alpha cells. And these are both inside of the pancreatic islet. So they both reside within there. All right, so that's humoral control and some of the key parts that we learned about there. We'll go ahead and stop there.